Hello friends, welcome to my channel Eccentric Learning. I hope you have gone through the first 5 parts of triangles where we have seen what are triangles and its properties, geometric centers of triangles, congruent and similar triangles, some important theorems and so on. In case if you haven't gone through those videos till now, the link has been given in the description box, please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. In today's video, we are going to see some problems based on the concepts and theorems that we have seen in the last video. That is problems based on similar triangles, basic proportionality theorem, and so on. I would request you all to go through the last video first, that is triangles part 5 video, and then to come back to this video to have a better understanding of the problems discussed in this video. Also, before seeing the solution of every question, I would suggest you all to attempt those questions from your end first and then to check the solution. So, let us begin with today's video. Let us begin with this question. We have been given a triangle PQR such that the length of the side PQ is given to be 12 units. The length of the side PR is given to be 9 units and the length of the side QR is given to be 13 units. U and V are the points on the side PQ and PR respectively such that UV is parallel to QR. So U is a point on the side PQ and V is a point on the side PR such that the line segment UV is parallel to the side QR. We have been also given the length of PV to be 6 units and we need to find the length of QU. Since U is a point on the side PQ and V is a point on the side PR and the line segment UV is parallel to QR, so the points U and V will divide the side PQ and PR in the same ratio simply using the basic proportionality theorem. So the ratio PU upon QU would be same as PV upon VR. And we have been given the length of PV to be 6 units and the length of PR to be 9 units. So the length of VR would be 9 minus 6, that is 3 units. So PV upon VR can be written as 6 by 3, which is 2 by 1. So PU upon QU is in the ratio 2:1. Now we know the length of PQ is given to be 12 units. So the length of QU can be written as 1 upon 1 plus 2 times of 12 units, which would be 1 by 3 of 12 units, that is 4 units. So the length of QU is 4 units, which we are able to find simply by using the basic proportionality theorem. Now let us see this question. In the given figure, DE is parallel to BC and 2 of AB is equal to thrice of AD. And area of triangle ADE is given to be 40 square units. We need to find the area of triangle ABC and the area of quadrilateral DECB. So ABC is a triangle and DE is parallel to BC. Since DE is parallel to BC, so if we consider the triangle ADE and triangle ABC, in that case, these two triangles would be similar triangles. Because if DE is parallel to BC, then this angle would be equal to this angle as they are corresponding angles. And this angle for triangle ADE is also equal to this angle of triangle ABC as they are also corresponding angles and angle A is common to the triangle ADE and triangle ABC. So all the three angles of triangle ADE and triangle ABC are equal. So triangle ADE and triangle ABC are similar triangles. We know in case of two similar triangles, the ratio of their areas would be equal to the ratio of the square of their corresponding sides. So the ratio of the area of triangle ADE upon the area of triangle ABC would be equal to AD square upon AB square. And it has been given that twice of AB is equal to thrice of AD. So AD upon AB can be written as 2 by 3. So AD square upon AB square would be 4 upon 9. So the ratio of the area of triangle ADE upon triangle ABC would be 4 upon 9. Now it has been given that the area of triangle ADE is 40 square units. So from this, the area of triangle ABC can be written as 9 by 4 times of area of triangle ADE, which would be 40. So this would be giving us 90 square units. So the area of triangle ABC would be 90 square units. Now we can find the area of the quadrilateral DECB simply by subtracting the area of triangle ADE from the area of triangle ABC. So the area of quadrilateral DECB can be simply written as the area of triangle ABC minus the area of triangle ADE, which would be 90 minus 40, that is 50 square units. So the area of quadrilateral DECB is 50 square units. So in this way, by using the concept of similar triangles, we can find such areas. Now let us see this question. We have been given a triangle ABC such that AF is to FC is in the ratio of 1:1. AE is to ED is in the ratio of 3:1. And we need to find the ratio BD is to DC. To find the ratio BD is to DC, let us construct a line from the point D on the side AC at point GC such that DG is parallel to the line BF. Now, if we consider triangle ADG, in that case, the point E is a point on the side AD, the point F is a point on the side AG, and the line EF is parallel to DG. So using basic proportionality theorem, we can say that the point E and F will divide the sides AD and AG in the same ratio. So AE upon ED would be same as AF upon FG. And we know AE is to ED is 3:1. So AF upon FG will also be in the ratio 3:1. Now AF is to FC is in the ratio of 1:1 and AF upon FG is in the ratio of 3:1. So from this we can say that FC upon FG will also be in the ratio of 3:1. Now FC upon FG are in the ratio of 3:1. So we can say that FG upon GC will be in the ratio of 1:2. Now, if we consider the triangle BFC, in that case, the point D is a point on the side BC the point G is a point on the side FC and the line DG is parallel to the third side BF. So using basic proportionality theorem again, we can say that the point D and G will divide the sides BC and FC in the same ratio. So we can say that BD upon DC will be same as FG upon GC. And FG upon GC is 1:2. So BD upon DC will also be 1:2. So the ratio BD is to DC would be in the ratio of 1:2. So in this way, simply by constructing a line parallel to BF and using basic proportionality theorem, we can find this ratio. Now let us see this question. In a right angle triangle PQR, QS is perpendicular dropped on the hypotenuse PR from the vertex Q as shown in this figure. The length of PQ is given to be 6 units. The length of QR is given to be 8 units. And we need to find the length of PS, SR and QS. And we also need to find the circumradii of triangle PQR, PQS and QSR. Since this is a right angle triangle, so we can directly use the Pythagoras theorem, which is hypotenuse square would be height square plus base square. So PR square can be written as PQ square plus QR square. The length of PQ is 6 units and the length of QR is 8 units. So this would be 6 square plus 8 square, which is 36 plus 64, that is 100. So PR square is 100. So the length of PR, that is the length of the hypotenuse, would be 10 units. Now PQR is a right angle at point Q, and from this right angle we are dropping a perpendicular on the hypotenuse PR at point S. And in the last video we have seen that if such is the case, then we can write 3 important relations, which are PQ square is equal to PS into PR, QR square is equal to PR into SR, and QS square is equal to PS into SR. Well, I have already explained how we can derive these 3 relations in the last video. So in case if you are having any difficulty to write this relation, you can refer to that video, the link of which I have given above and also in the description box. Now we already know the length of PQ, which is 6 units, the length of QR, which is 8 units, and the length of PR is 10 units. So from the first relation, we can write 6 square is equal to PS into 10, which will give us the length of PS to be 3.6 units. In a similar way, from the second relation, we can write 8 square equal to 10 times of SR. So from this, the length of SR would be 6.4 units. And from the third relation, QS square is equal to PS into SR. So QS square would be equal to PS into SR, that is 3.6 times of 6.4. From this, the length of QS can be determined, which would be 4.8 units. So the length of PS is 3.6 units, the length of SR is 6.4 units, and the length of QS is 4.8 units. Now we know in case of a right angle triangle, the length of the circumradius is half of the length of the hypotenuse. So for the triangle PQR, which is a right angle triangle, right angle at Q, the length of the circumradius would be half of the length of the hypotenuse, that is half of the length of PR, which would be 5 units. In a similar way, PQS is a right angle at S. So the circumradius for triangle PQS would be half of the length of its hypotenuse, which would be half of PQ, that is 3 units. In a similar way, the triangle QSR is a right angle at S. So the circumradius of triangle QSR would be half of the length of its hypotenuse, which would be half of QR, that is 4 units. So simply by using this concept that in case of a right angle triangle, the length of the circumradius is half of the length of the hypotenuse, we can calculate the circumradii for such right angle triangles. So in this way, by knowing some important relations and concepts, we can calculate such lengths and circumradii for right angle triangles. So that's it for today's video, in which we have seen some problems based on the concept of similar triangles, basic proportionality theorem, and so on. And with this, we come to an end of triangles topic from geometry, where we have seen many concepts and some basic problems as well. But I would suggest you all to practice some more questions from triangles, because the more you practice, the more you learn. In the next video, we'll be continuing with quadrilaterals like parallelogram, rectangle, trapezium, and so on, which should be followed by polygons, circles, and then mensuration. I hope you have learned something from the triangles videos, but if you have any confusion, you can watch those videos again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel and also share with your friends. I will see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.